That sounds great. Thank you, John. All right, so let's get going. So hi, everybody. It is 7 p.m. Eastern Standard Time, so we are going to get started. As you can see, we're once again broadcasting live from the Scholastic Education Studio here in my dining room. As always, I'd like to start off with a big shout out to our educators, of course. It has been a roller coaster of a year, to say the very least. A lot of roller coasters with a lot of dips, unfortunately. And all of you just keep showing up for our kids and our families. And I know how hard it is. A lot of my family members are educators. And I just want to let you know how grateful we are that you could join us tonight. And big cyber love, big hugs from the Scholastic family to yours. So my name is Sean Campbell, and I am the Digital Resources Manager with Scholastic Education. Tonight, we are very fortunate to have the amazing Diane Stang join us for our virtual workshop series. Tonight, Diane will be leading this session that focuses on the new Ontario math curriculum for grades 1 to 3. At Scholastic Education, we are incredibly fortunate to also have Diane as the lead author and editor of our new math resource, Math Place, which is perfectly aligned with the new Ontario curriculum. So you'll see some of those strategies from that resource as well this evening. Please ask any questions using the Q&A button. We will do our best to answer as many as we can. And of course, we'll try and leave some time at the end for questions as well. I'll also post a link in the chat probably a few times so that you can find your local Scholastic representative. If you have any questions later on or would like more information on Math Place, just give them a shout. They're great. Everyone's super friendly and happy to help in any way they can. And of course, just so you're all aware, the session is being recorded. We do have some hashtags for all of you in the Twitterverse this evening. If you're tweeting about this session, whoops, there we go. So we can use hashtag ScholasticEdPD. Or tag us on Twitter at ScholasticEdCDA. That would be great so that we can continue the conversation online. And then one last thing before we get started, I went over my slideshow there, so you might have seen it. We are going to do a door prize tonight. So I'll post a link in the chat a few times tonight. And if you want to win a Math Place Grade 1 Ontario number and financial literacy kit, just fill out the form. It's an online form, Google form. You just fill it out, submit it, and that will be your entry into the draw. And then we'll do the draw later this week, and we'll contact the winner. So good luck to all of you. Don't forget to submit an entry form for that. So without further ado, I would now like to introduce Diane Stang. Diane has been an educator for over 40 years, working in various roles in the classroom, at the ministry level, and now as national math consultant and lead author of Math Place here with Scholastic Education. Her tried and true classroom tested lessons, coupled with her practical approach to math, empowers teachers to teach math in an authentic, meaningful way. Diane integrates professional development in every part of the resource, building growth mindsets, math talks, spatial reasoning, visualization, and a balanced math approach to meet the needs of all students. So without further ado, Diane, over to you, and thank you so much for joining us for this session.
Thank you very much, Sean, and welcome everybody. I'm delighted to be here. And like Sean said, I'm really excited that you came out on a Wednesday evening in the midst of this turbulent year to be able to join us today. So I'm very excited. There is a new curriculum. As Sean said, I've been in education for over 40 years, so I've seen a lot of curriculum come and go. And so I've had to interpret a lot of curriculum, not just in math, but in many other subjects. And what happens every time a new curriculum comes out is we've got to start looking for those resources that will help us and support us. And I know, as Sean said, I'm very practical. I'm always looking at what are the changes in the curriculum, but how can I address them? So what we're looking at tonight we're going to look at a lot of the changes that are in the curriculum. We're also going to look at what this means to your math program. And then finally, what are some of the strategies and some of the resources that we can use in order to meet these in a practical and efficient manner. So without further ado, what I'm going to do is I'm going to share my screen now, and I'm going to turn my camera off so you're not looking at me, but you're looking at my presentation here. So I'm just going to stop that for a second. And I'm going to share my screen. And if technology goes the way it's supposed to, there we have it. Okay. So like I said, before I begin, just hang on a second. One technical difficulty already. Okay, there we go. So I want to do a land acknowledgement. Today, I am very fortunate to be presenting on the traditional lands of the Haudenosaunee people. And as we engage in this session, we honor Indigenous history and culture and are committed to moving forward in the spirit of reconciliation and respect for all First Nation, Métis, and Inuit people. And for those people, I am actually on Lake Simcoe. And these are some of the beautiful sunsets that we do see from this glorious land. Excuse me. So like I said, our mission today is to understand some of the changes to the Ontario New Math curriculum, understand what they mean to your program. And like I said, we're really going to look at strategies and resources as well. So you may ask, why Math Place? Why did I develop Math Place? Well, I'll tell you, after traveling around the province in my job at the ministry and working in my board, teachers were always saying to me, why don't you create a resource? Why don't you create a resource? Because in grades 1 to 3, it's really hard to find something that is comprehensive, that you can follow. It doesn't have to be prescriptive, but everything's there. And I thought, yeah, that's a great idea, but that's a lot of work. So I thought, well, when I semi-retired, I thought, well, maybe this would be a good time to do it. So I've actually worked the last 4 years on it, and I've updated it so it aligned with the new curriculum, which wasn't too hard because a lot of the big ideas have not changed. The big ideas in math do not change. They are still there. It's just sort of our focus on it. So that's what I did. And when I developed it, I wanted to make sure that this was a program that was comprehensive. In other words, it could be your whole math program if you wanted it to be. It perfectly aligns with the curriculum, so you don't have to worry about that. Also, it is flexible to use. It's not prescriptive in any nature. Like I said, it can be your whole program. You can pull from places in there and put it together. So there's a lot of flexibility to using it. It's based on research and developmental strategies. And it's developmental trajectory, how students learn. And this is really important to me. I've done a lot of research throughout the years on mathematical learning. And so this is really dear and near to my heart. So basically, all of the math builds upon the foundational concepts that were taught before it. And finally, one thing that I wanted to do is I wanted to fill this resource with a lot of supporting details that we need. In other words, I always found I get a good idea for a lesson, but then my problem was, well, where am I going to find a black line master that will go with that? I guess I'll have to make it. Or I need an image for this. You know, where can I find one of these images? Or I need a book from the library. And this used to frustrate me and really slow me down in my process. So these are all the things that are included, just so you get an idea. This is not just a book. It, as you can see, is a whole kit. Comes in this great box. First of all, you get the teacher's guide that has all, it has embedded professional learning, which I'll talk about a little bit later. It's got detailed 3-part lessons in it for you to follow, and they all build upon each other. There's math talks in there to develop those mental math strategies, to develop spatial reasoning, and there's lots of further practice and reinforcement skills. And like I said, it all aligns with the curriculum. There are read alouds in there. And I should say, if you're not interested in Math Place, that's fine. You can do this. You can apply a lot of the strategies that I'm going to be talking about tonight, but you would have to gather up your own resources to do it. But there's a lot of strategies in here that will show you how to meet the new needs of the curriculum. Anyways, I really strongly believe in making that connection to literacy. So we have included in these kits some great read alouds. What I tend to do with the read alouds is, in the lessons you'll see, we read through it once using our reading comprehension skills, really understanding what the story is all about, and then we read it a second time as math detectives. We also have included some little books for guided math lessons. Guided math lessons are sort of like guided reading lessons. We know we should be doing them, but they're not always the easiest thing to do in the world, because what are the rest of the kids doing when I'm differentiating my instruction for a small group of kids? We've included lessons in here that say exactly what you can do with your other kids while you're doing this. great ways to differentiate your lessons. These little books are great. They're high floor, low ceiling. So there's tons of entry points, lots of ways for you to differentiate with the same book. So kids are still somewhat on the same page, but you'll be able to differentiate the instruction throughout. I have included Black Line Masters because, and there's lots of things. There's graphic organizers in there. There's extra questions and problems in there. There's reproducibles like the money you can see there. And so you don't have to go looking. We've tried to really make this easy. We've also included digital slides. This is one of my favorite things because as you see when you go through here, I'm really interested in spatial reasoning and getting kids thinking spatially. So we have lots of colorful slides that you don't have to go looking for. They're great for math talks. You just have to throw them up on your whiteboard and away you go. And they're excellent for virtual learning. When I was teaching, I loved big books. So I insisted that we have a big book. What they did this time is they made it a digital big book, but there are 8 little books that go along with it. I'm really excited about them because again, they're those visuals to develop that spatial reasoning and develop the context for math and a lot of practice. So there's lots of colorful images within these books that you can use with your students. A lot of the pictures contain problems that the kids will solve. And a lot of the pictures have math talks that you can do over and over again. So you can reuse the book quite a bit. Excuse me. And also there is a website with additional resources. Like I said, I'm trying to show that this is something you just open it, you get some concrete materials and you're ready to go with this. So let's start off by looking at, excuse me, the curriculum and the front matter. Now, when we open a curriculum, a new curriculum, we tend to go right to our grade and find out we have to teach what the changes are. But we really have to look at that front matter because it sets the tone for what the whole curriculum is like and why they have arranged things the way they have and where the emphasis lie. So when we're looking, we can see that the vision is that all students develop positive identity and are given support to make sense of math in their world and make critical decisions. Okay, the goals are to understand and appreciate the beauty and importance of math. And I can't agree with that any more than that. We want kids to be able to adapt to change and synthesize new ideas, work independently and collaboratively, to think critically and creatively, which is of course those transferable skills that we want throughout all of our courses that the students are studying, communicate effectively, appreciate multiple math perspectives. In other words, what other people in the class are seeing, and make informed decisions, which is what they're going to need in the world once they leave and they're dealing with math in their everyday lives. So as you can see, this is a whole student perspective. We want students to build confidence, develop positive attitudes toward math, cope with stress and anxiety, persevere and learn from mistakes. That's a big one. Work, we've already said, work collaboratively and independently, value deep thinking. And so, in my opinion, this is number 1. It always has been, as far as I'm concerned. If we don't get those attitudes about math instilled in those kids, that they can see it as something worthwhile to learn, if students don't see themselves as good, capable learners, we're going to have a barrier there. Now, the whole thing is, this has been a tumultuous year, as everyone has seen. This COVID-19 is something I've never seen in all of my years of teaching, and my heart goes out for you. You're probably thinking, geez, just within a pandemic, we have to get a new curriculum too. And you're thinking, okay, you may lack the confidence in being able to teach it at this point because you feel so frustrated with the virtual learning and changing and whatnot. Your kids may feel that they have gaps, they don't have the same confidence. But my message is, if you have to take the whole month of September and half of October to break through and just get positive attitudes in your class about math and have your kids to develop that self-confidence, it's worth it. You won't get anywhere unless you do that first. I've tried and it doesn't work. So slow down and take the time to do this, number 1. The curriculum has taken this into account by putting into the curriculum the social emotional learning skills. And we're going to talk a little bit about that more. As educators, our number 1 thing is to not say to them, well, I really didn't like math when I was a kid either. We are there to motivate and inspire them. be able to help them see the beauty of math and how exciting and interesting it can be. Number two, of ultimate importance is understanding the math. And this is what I really discovered across the province. And in my own teaching, I found what happened in a lot of cases was I would be in the midst of teaching a lesson. I would all of a sudden go, oh my goodness, I now understand conceptually what I learned by rote when I was at school. Those aha moments are the ones that really help us convey our ideas to our students. So what I've done in all of my resources is identified what the big ideas are. And I'm going to show you how I've done that. But like I said before, the big ideas have not changed from the last curriculum in 2005. They are still there. It's just the focus and emphasis. So we want to know what the big ideas are and how they connect to our lives. To help, in all of my lessons, every one of my lessons, there is an about the math section. Someone already asked, who are some math leaders that you would follow? Well, some of them are listed right here on this screen. And what I've done is I've written about the math in front of every lesson so you know what the math is about and why it matters. And there are also citations in there so you can look up and further read about some of these ideas. To me, this is really important. And as you go through and you do more and more lessons, you're going to learn more and more about the math. So here are the highlights we're looking at today, the changes. We're going to look at the 6 strands instead of 5. We're going to look at embedding those social emotional learning skills throughout the year, not just at the beginning or in the middle. We're going to look at the high impact instructional practices that they put into the curriculum. This is something that's brand new, this mathematical modeling process, which I want to explain. Coding concepts are now in the curriculum. Spatial sense is probably the most changed as far as all of the strands go, so I want to explain that. I also want to talk about financial literacy as a strand because that is brand new. And also this whole idea of balancing conceptual understanding and math skills. And if we have time, any other changes that we see within the strands. So first of all, we have to talk about assessment and evaluation, some of the changes that we've seen. It's still based on growing success. And we're still looking at an assessment for learning, those observations, conversations, and products, and how we can triangulate the evidence. That is the same. What has changed is, as you probably already know, because you've been writing report cards, is now there was one overall grade or mark for math based on the integrated learning across the strands. And what happens is we can comment about the individual strands within the comments that we're making. So here are the revised strands. You can see we have social emotional learning skills and mathematical processes. We have number, which of course is a good part of our curriculum that we're looking at. We have algebra, data, spatial sense, and then financial literacy. Social emotional learning skills, they pretty much permeate all of the other strands. So it's not, we're going to treat this as a separate strand. This is one that we are going to integrate in all of the other strands all throughout the year. Here are the social emotional learning skills. There are 6 different ones, as you can read them for yourselves on the screen, but these are the ones that we want to focus on. So the way that I've done it within Math Place, I started with some introductory lessons that will help introduce the social emotional learning skills. So for instance, these are some of the books that I've included and using in order to introduce those skills. We read the book, we talk with the kids, and there's all lessons with this. And what happens is we develop those social emotional learning skills. We make a nice anchor chart in our room so the kids can see what they are. Then what we're going to do is we have to make sure that we reinforce those throughout the year. The reason this is important is because we have to assess and evaluate them. So what I've done in not all of the lessons, but I'd say in almost all of the lessons, is I put in a section called Building Social Emotional Learning Skills. And you can see what I've done is I've highlighted which social emotional learning skill I'm highlighting in that lesson. In this way, this gives you some idea of how you can reinforce social emotional learning skills within the context of the lesson that you just did. This way, this helps you with your regular assessment and evaluation. You have those anchor charts and you're going to continually refer to them throughout the year. This will help kids see the progress that they're making as they're feeling more confident in their learning. And this will help you too, if you're looking at them, being able to balance those 6. So you can really zero in on all 6 of them and see which kids need which social emotional learning skills to be developed further. I also do this, and I have a lesson in Math Place that does this. What does a mathematician do? We have a great lesson in there that introduces a concept to the students, and what they have to do is they have to think about what mathematicians do. We also make an anchor chart of that in the year, and we refer to it frequently during the year so the kids feel like they are mathematicians as they go through the year. This is really important. Like I said, if it takes all September, do it. Sorry. Okay, so the next important strand, of course, is going to be number, and we're looking at quantity and counting in here, and as well as operations. And quantity and counting, of course, also refers to fractions. This we're also going to infiltrate into all of the other strands. For instance, when we're doing data and kids are looking at graphs and they're comparing the bars in the graph, they're doing quantity and counting. Spatial sense I'm highlighting because it has changed. Geometry, measurement, and location and movement are within there now. And I'll explain why these are going together, because they all have to do with spatial reasoning. Spatial reasoning is something they identify, or they call it spatial thinking, in the curriculum that is throughout all the curricula, and it is especially in math. So what we want to make sure is that we are taking that spatial reasoning and we are integrating it into all of the other strands. The research indicates that there is a high correlation between how well students do in spatial reasoning and how well they do in math. That's from the beginning of kindergarten right up into high school. So that's an area that if we improve their spatial reasoning, we will also improve their math achievement. Data, it concerns data literacy and probability, much like before. And again, we're going to work at infiltrating these into our other strands. Algebra is different. We have patterns. We also have equality and inequality, which we've had before, but we also have coding concepts and mathematical modeling. The interesting thing about this is coding concepts and mathematical modeling are actually very much evident in all of the other strands. This is because the other strands give the context for being able to do the coding concepts and the mathematical modeling. I'll be giving you some examples later on. Okay, so what we're looking at is not teaching a strand, then leaving it alone for the rest of the year. What we're looking at is being able to spiral the math strands. In other words, we're going to visit number and operations. Maybe we'll do numbers to 20. Then we're going to go off and do something else, but we're going to come back to that. And we want to make sure, because this is what reinforces the big ideas for the students as we're going through the year. And we can do this around big ideas. So for instance, this is a great idea of looking at it. And this is why understanding the big ideas is so important. You think, where is sorting, for instance? That's a big idea. Where is sorting in all of the other strands? So what you want to do is take those big ideas of sorting, and when you're in those other strands, you want to really make sure that you're reinforcing those ideas. Think of how many times those kids are visiting sorting throughout the year. They're going to become real pros at it by the time they've gone through the year. Now, something that is also in the curriculum that you may not have discovered yet is they have suggested, and I use the word suggested, long-range plans. It doesn't mean you have to use them, but they're trying to get away from teaching a strand as a block and a strand as a block, and we never visit them again. So here are some suggestions. And like I said, it took me a long time to be able to teach math where I could teach several strands at the same time. So don't panic about it. You have to go at your own pace when you're comfortable about it. But here's some ways to be able to try it out. So you'll notice for grade 1, 2, and 3, the theme is always who are we? I'm just going to show with the grade 1 what we're talking about here. We're doing some data collection, visualization, data analysis. We're doing counting to 20. And we're doing relative locations and directions for movement. As you can see, we're looking at number, data, and spatial sense. 3 strands there. Well, what I've done in Math Places, you can see here are all the units that are within number and financial literacy of that resource. What you can do very easily, then you think, oh, okay, we're doing counting to 20. Well, all I have to do is pull out the lessons that go along with this unit then. I'm going to work those. Okay. During those lessons, what you're going to be doing is you're going to be counting, you're having the kids count, doing investigations about counting, working with concrete materials. They're going to be both counters, counting collections, and producers making connections of a certain amount. They're going to be able to count when on this kind of an activity where they've now moved from concrete materials to something that is more two-dimensional. So they have to have different counting and tracking methods to do that. Then it says, okay, you're also going to be doing collecting and organizing data. Okay, well, I can pull lessons from there, from my data. And why is this so important at the beginning of the year? This is from Guides to Effective Instruction in Mathematics. What a great way to be able to do this is to be able to do a survey every day using concrete materials. You can do these virtually online if you're working that way, but this is a way to get to know each other and build that math community. What are kids doing? They're also comparing numbers and counting to 20. So you can see how we are meshing those strands together. They also mentioned location and movement. Well, kids in grade 1 have to learn a lot about the language that is used when we're talking about relative location, such as under and over. So what better way than to start at the beginning? Kids can use a lot of input with visuals, such as this messy room here, where they have to describe how things move from the messy room to the organized room. Or they're working on a grid and they have to match those street signs to the way that the streets actually move. Or one of my favorite are using barrier games. And barrier games are where students are telling each other instructions, they're giving and taking instructions. So this is a great way that you can take these three and mesh them together. And this could be your beginning September, along with introducing those special social emotional learning skills. What all of these activities you can see have, there's a lot of fun, motivating activities to do to get them to get excited about the math. Okay, so some underlying principles of the math curriculum that we haven't mentioned already: values and celebrates diversity. I've tried to include a lot of diversity within this resource. It provides all students with foundational concepts and skills. Again, it's balanced. They also acknowledge that learning is dynamic, continuous, and coherent. That's one thing I've really tried to do, so lessons all build upon each other, and it integrates with the world beyond the classroom. They really recommend in the new curriculum as going cross-curricular, and I've done this very much so, along with my excellent writers, by the way, in Math Place. Lots of books that you can use in the literacy to be able to set the context for the math. In the arts, we can use a lot of arts from various cultures. I've included a lot of these to be able to show students some of the diversity that is across the province and be able to talk about some of the different shapes that we see, two-dimensional, three-dimensional. A lot of things to do with music. Students can use patterns to be able to create rhythms and beats. And then there's drama where kids can act out stories like we're going on a lion hunt. Cross-curricular and science is so important, and the themes living and non-living things really lead to that kind of integration. You can see here, we've got things about animals, we've got things about plants, which is grade 3, and we also have stable structures where students, as you'll find out in grade 3, are working with nets when they're dealing with three-dimensional objects. And again, cross-curricular social studies, we can do grade 2 celebrations, and we can also do geographic factors. So we have taken care to incorporate all of this within the resource. Okay, here's a document that goes along with the curriculum. It is called, I'm sorry I'm going so fast, but I just have a lot to say today. Okay, these are high impact instructional practices in math. And basically, this is what I call good pedagogy. It's things that we've been doing for years, but they're really highlighting a lot of them in here. And this is something that they really want you to integrate into your programs. We've done this in Math Place. We've aligned all of them. And I'm going to show you in a 3-part lesson how you can integrate all of these kind of high impact practices. So if you're looking at a 3-part lesson, this is one 3-part lesson from Math Place. It's about representing separating problems. So students are working at a concrete level, understanding what subtraction is. We always start with the math curriculum expectations and the mathematical processes, because this sets us up for what we're going to be learning. There's always a possible learning goal there. The reason we say possible is because you may want to change it. And that's important because you want to adjust everything to your own students. There are also teacher look for. So what are you going to be looking for throughout the lesson? Now, keep in mind this learning goal or these learning goals and these teacher look fors are for you, right? If we put those up in the classroom like we often do in literacy, kids will follow it like a recipe rather than trying to solve the problem on their own and come up with their own ways of solving it. So what we want to do is we're going to use these to guide us through the lesson. Then when we come to the consolidation, we can develop with our kids the learning goal for the lesson and success criteria, which often flows from a lot of the teacher look fors that we developed. There is your about the math section that tells you what is happening in that math and why it's important. Here with our high impact instructional practices, we're looking at learning goals and success criteria. In this one lesson, then you can see we want to use a variety of concrete objects. This is the high impact and instructional practice of tools and representations. And like I said, all you have to do is get some concrete materials. The rest are all included in the kit. Minds on. This is when we're providing activities to students. Any three-part lesson, this is what we want to do, which is where we're really focusing on those math conversations with our kids and making sure there's just not teacher, student, but teacher, student, so there's active listening happening. During the working on it, this is when we assign those rich problems and we have the kids either working independently or in pairs or in small groups. So we're problem solving with the kids. We're also using flexible groupings. This is important because we want all of our kids to work with other kids. You'll notice that in math place in the primary, I usually have them working in pairs. The reason is I found with smaller groups, often 2 kids go to sleep if there's 4 and the other 2 are doing the work. So it's kind of nice to be able to have them work in pairs and then from time to time get those pairs together and they can work as a foursome. There's also differentiation included. This is important because our kids are not working all at the same place and we need to make sure that they have entry points and they also have support. There's also assessment for learning. Remember, we talked about observations, conversations, and products. Those products flow naturally from the work that we're doing, but here we're outlining those observations and conversations that you can make to help you. And this allows for us to do small group instruction and descriptive feedback. So if you've planned a really good 3-part lesson, you are really looking at all of those high impact instructional practices. Our consolidation, moving on, is where we, like I already said, come up, we're talking about the math problem solving that we did, we're sharing strategies. This is where our direct instruction comes in. Now, direct instruction is not where I stand up and give a lecture on something. What it is it's intentional and it's focused, but it's often based on questions. So it's very interactive as well. And our whole point to this direct instruction is to be able to clarify ideas. This is new. It was there before, but it wasn't explicit in the curriculum. But this is something that you can feel comfortable to do because we want kids by the end of the consolidation to have a solid understanding with not all that messiness there anymore, that they do understand what the big idea of the lesson was. Here is an example or where I have built in social emotional learning skills. So during this time, this is a great time for, in this case, we're looking at stress management and coping. This way, throughout the lessons, you can assess and evaluate where your kids are in that growth. And then finally, we know that deliberate practice is important. So that's something else we build in as further practice. And finally, there are math talks. And you'll notice with this math talk, we actually put in possible conversations, things that kids may say, and then it gives us an idea of how to respond. Because often we know what we want to ask, but we're really not sure what we want to say once the kids have responded to us. So those are the high impact instructional practices in the curriculum that we want to incorporate into our lessons. Now, this is something that is new. This is the mathematical modeling process. And this provides authentic connections to real life situations. So this is something you want to give your kids when they are solving problems within the context of a real life situation. You'll notice that there are 4 components in it, but they are not to be done in order, in a recipe order, number 1, number 2, number 3, number 4. The whole idea of the mathematical modeling process is we approach it as a whole. And what we're doing is we're moving freely and liquidly as we need to through and back and forth among the 4 key components. In other words, it's very iterative. So for instance, we want the students to understand the problem. So we may present the problem. We may want to clarify with them what is being asked, what information do they need. Then we need them to analyze the situation. So within that context, what assumptions can they make and what changes and what remains the same? Then from there, they create a mathematical model. Now, looking at this realistically, because this is the mathematical modeling process that is the same right through all the grades, they're not going to be able to create their mathematical models right off the bat. They're just not. So what you can look at in this sense in the grades 1 and 3 is you're going to start by creating a mathematical model together. You're going to collaborate together and create this mathematical model. Then when you can do this in the mind's eye. Then when the kids are working, and they're working on it, this is where they can select maybe their own materials, or maybe they adapt the model a little bit. You may find that while they're working, some of the kids are having difficulties. This is when you can pull a group and it becomes iterative in the process. You take them back to analyzing the situation, or you take them back to the problem to make sure they understand it. Once you've done all of this, then you're going to analyze and assess the model. Can this model be applied to another situation? If I was to do it, how would I change it? So it's very iterative in nature. You'll notice again that it's in the algebra strand, but it would really be in all of the other strands. Here's an example. Here's a lesson that we have. It's a shoe store, and the kids are supposed to count the shoes. Now, you can differentiate the task to how many shoes or whatever you want. But the math concepts that we're getting at are the stable order of our number system, and counting the same set in different ways results in the same total. Okay, these are really important. So the question you can say, well, we're going to count the shoes. What do you understand? Okay, so the kids may say, well, I know I have to count the shoes. Okay, that's great. How many shoes do I have to count? All right, that's great. Let's assess the situation. Do slippers count as shoes? Do roller skates count as shoes? Do I just count the red shoes? You're analyzing all of these together. Once you've done that, then the kids are going to decide on their counting strategies. Maybe they're going to count by twos. Maybe they're going to count some groups and put them together. They're going to do some subgroups, but maybe they're going to start at one end while another group starts at another end. And then the big aha is, oh, look, we had different strategies, but we came up with the same amounts. Then finally, what you're going to do in the consolidation is you're going to analyze and assess the model that you used, what you might change next time, what really worked, what didn't. So that's one example of how this mathematical modeling can be used. Like I said, you use it in its entirety. So, and just keep looking at it as being an iterative, messy process. And like I said, in the primary grades, I think if we just give them a taste for it, they're going to get more independent at using it later. But we can still have an anchor chart in our room, point out these 4 steps and say, oh, look, we really are having difficulty with our model. Let's see if we understand the problem first and show them how they're moving back throughout it. There are coding concepts. Again, this is in the algebra section, but this can be integrated into all of these sections. So let's just look at what code is, first of all. We know it's a series of instructions given to a computer to carry out a specific task or achieve a desired outcome. Kids have to follow code. They also have to write and alter code. This requires logical and computational thinking. The coding concepts are as such. In grade 1, kids are working with sequence of events, a series of instructions carried out in a certain order. In grade 2, they're doing sequence of events, but they're adding in concurrent events. And then in grade 3, they're doing sequence and concurrent events, but they're also doing repeating events. So here's some examples of how we can do this. We can build coding into our program without a computer, because think about it, it's following instructions and giving instructions, much like we were talking about when we were looking at location and movement, the development of spatial language. We can have kids have had experience maybe working on grids. we can then do this. And this is actually adapted from a book called Taking Shape by Joan Moss and her colleagues. I encourage you all to read it. But basically, I've worked this into the math place as well. So kids are either creating the code or they have to follow the code. Now, how do you start this off in the year? Well, you're going to build a grid on the floor in your classroom, and kids are going to give directions, and these kids are actually going to move kinesthetically across their grid. This is how they're really going to understand whether the coding works or not, because if the instructions aren't going where they're supposed to take them, then they know they have to adjust them. You can get them to find alternate ways to the same place. You can say to them, then let's switch up the order of the code. Let's see if the code still works if we have it in a different place. In a lot of cases, then you can create barriers in your grid. And in this way, the code will make a difference. The order will make a difference. So you want kids to be able to find out what they have to do as far as their code goes in order to make it happen. It doesn't just land in there, though. You can also do it in number. Here's a great example. One of the lessons in there has to do with sequence of events, this magical mix-up where there are these instructions. So order number one, we're going to start with 8, and we're going to take 2 of those instructions. The first is take out half, put in 4 balls. Have the kids experiment with that, and they discover, oh, look, there are 8 balls. Okay. Tell them, we'll mix up the instructions, see what happens then. We put in 4 this time first and then take out half, and look, at lo and behold, we get 6 balls. Kids are learning that the order of their instructions makes a difference. So they can then start creating their own orders and then giving them to friends and seeing whether they're getting their desired outcomes. Grade 4 or grade 3 is a lot of fun. This is looping or coming up with repeating events. You can do this on something like a snakes and ladders game. So if we're looking at role 4, the kids can either work on one that would create a loop, or they can create their own board to make a loop. So example, roll 4. We're starting at the beginning. We roll 4. We roll 4 again. Oh, it says move 5 + 3 spaces ahead, which puts us here, which takes us down here. We roll 4 again, because that's what we're supposed to do. And guess what? We're in a loop. So the kids can have a lot of fun with this. So there's some examples of how we've taken coding out away from the computer, and we've embedded it in number, and we've embedded it in location and movement, which is spatial sense. Spatial sense. Like I said, this is the strand that has changed the most. We now have geometry, in my opinion, geometry, measurement, and location and movement in here. And let's think about it. Geometry and measurement belong together, because in geometry, we're studying attributes and properties. Measurement, we're measuring those attributes. There's been a lot of change in these areas, which I want to go through. And so first of all, this is geometry grades 1, 2, and 3. You'll notice that students in grade 1 are looking at attributes of 2D shapes and 3D objects, not just their properties, but also just attributes, their color, their texture, things that don't affect what kind of a shape they are, but they are attributes. Grade 2, they only deal with 2D shapes. They also deal with congruence. So they're looking at whether shapes have the same size and the same shape. Grade 3 are only dealing with 3D objects and congruence. There's a great emphasis on spatial reasoning here. We want to be able to tie this into what the shapes and into the students' real life context. So we want to make sure that we are showing students shapes in their environment, right? So this would be something they could be doing in grade 3. And we want kids to be able to visualize. Visualize is basically thinking with the mind's eye, using our imagination to generate and retain images. These images that we get from working with concrete materials, and then retrieve those stored images, and most importantly, be able to transform those images. Too often we deal with static images. We don't worry about the transformation, and that's something we as adults have to work on, and kids do too. So that's something we want to work on in the spatial reasoning. So for instance, we can describe to the kids, this is one thing that you can do, describe to the kids a configuration like this, and then see if they can work to be able to visualize it in their mind. And this is what they see. Don't stop there though. Have them turn it upside down and see whether they can visualize doing that. It's a lot of fun. You'll find that these are spatial math talks. We do number talks. These are math talks, but these are more spatial in nature. This spatialization carries off into number. We may want them to visualize 10 using their 10 frame experiences rather than seeing 10 as 1, 0. We may say twice as many. We want kids to realize that 20 is double 10, not just bigger, but double, and that 5 would be half as many. So visualization is something that we want to build into the program, and I do that a lot in math plays using math talks. For instance, in grade 3, perspective taking. You say to the kids, how many blocks are in this tower? Well, they almost have to, in their minds, walk around to the other side to be able to figure out how many blocks there are, right? Really gets them thinking from another perspective. This is a lot of fun. Again, this is taken from Taking Shape as well. This has to do with paper folding and visualizing. You can paper fold the paper right in front of the kids, or you can just show them the instructions. You punch a hole in them and say to the kids, how do you think it's going to look when we open it up? Let's try different ways. You can use holes in a paper punch to do this. And like I said, you can start by doing it right in front of the kids, or you can just have them later on looking at the instructions and visualizing folding the paper themselves. You can also, this is what they would get when it opens up, but you can also do different things like cutting corners. Cutting corners will, of course, end up with different shapes. So you can do this throughout the years. And while you're doing this, you are building that visualization that kids need and that spatial reasoning. Grade 2, they're only doing two-dimensional shapes. So why not have them do mental rotation with this? Say, okay, imagine turning some of those shapes around in the air, and how could we make squares out of them? You may want to differentiate this by have them actually working, show them a black line master, have them cut them out first, have them work with them first, and then eventually be able to do them more on a mental basis. When we're looking at spatial reasoning again, we're looking at composing and decomposing is huge because it also leads to composing and decomposing of numbers. So I'm just going to show you quickly a developmental trajectory. That's how kids go through to be able to learn to compose and decompose. I'm just going to go through it quickly so you get an idea of what I'm talking about, why Math Place is built upon these premises. This doesn't mean that all kids follow the same general pattern. They may skip some steps, or they may spend longer in one than another, but it gives us a little bit of a road map. So kids at first are piece assemblers. You'll notice what they're doing is they're keeping the pieces separate. They're just attaching at the vertices. They're not seeing them as being a composite shape. They're seeing them as separate shapes. They become picture makers. When we're giving them something to cover them, we want them to visualize those shapes in there. We may put those inner lines there first for them to be able to see where the shapes are going to be. And then as we're going through it, they become picture makers again. But this time, what's happened is we're only given the outer lines or just a few inner lines. So they're building from the pattern that they did. If you look at the caterpillar on the right, the caterpillar that they developed, and then what they're doing is they are then extending it to be able to fill it in a little bit more on their own. They become shape composers. They're now making shapes with more intentionality, and they're putting the shapes together to create what they want. And then they become the substitution composers. This is important because what they're doing is developing proportional reasoning. They're realizing that anything that takes a hexagon can also be covered by 2 red trapezoids. This is all built into Math Place as well, going through these kind of trajectories. There's lots of activities and BLMs for the kids to do with this, and it's a lot of fun and they love it. And why is it important? Like I said before, it's linked to composing and decomposing numbers. The research says that if kids can compose and decompose shapes, they're better off with decomposing numbers, especially any part-whole relationships such as fractions. Measurement, lots of changes here. You'll notice in grade 1, they're identifying attributes. That includes length, area, mass, capacity, and angle. They're directly comparing length, area, mass, and capacity. Look what happens in grade 2. They only focus on length, width, height, distance. They're using non-standard and standard units of a centimeter and a meter. That's it. That's all they cover. So it's very intense. Grade 3, they're looking at length. That is the main focus again. Length also includes perimeter. They want kids to see perimeter as just an extension of length because that's all it is. We're looking at a lot of lengths and putting them together. They're looking at area. in terms of non-standard and standard units, with the standard unit being a centimeter squared. Capacity and mass, they used to work in liters and grams, and now they're not. Now they're working only in non-standard units. They've slowed this process down so kids really understand what these attributes are and conceptually understand what the how to calculate them rather than being caught up with the numbers. So in grade 1, they're looking at different kinds of attributes: the shortest, how long something lives, how heavy something is, how tall something is. They're looking at direct comparison. So they're not using non-standard units. So for instance, they're taking their lengths and they're putting them with a common baseline and they're measuring them this way. So that's a big change. Grade 2, like I said, it's only length. Here is an example of a cool facts bugs book that we're working on. And what we've done in this book is we've put the bugs in at the actual sizes that they are. So the kids can have a lot of fun comparing them just visually by saying, oh, wow, look at how small that carpenter ant is compared to the Titan beetle. Then the kids can find different ways of measuring them, either length, they can do width, they can do wing size, doesn't matter, but they can use non-standard standard units. So this is why it gets so in depth with length. Grade 3, here you can see what we're doing is we're trying to tie, they're now working with millimeters and kilometers. We're trying to tie that into their science that has to do with plants and growing, a lot of different activities that they can do here with the length. As far as I already mentioned about perimeter, they want perimeter to be an extension of length. But here is an example where geometry and math go together. Kids have got to be able to measure the perimeters of these polygons. Now think about it. If they know that a square has 4 equal sides, then they only need the length of one side to be able to figure out the perimeter. So again, with measurement of area, it's non-standard and standard units. They're measuring butterfly gardens in this way. And then if you're looking at the mass and capacity, they're using non-standard units. And you'll notice they're using pan balances, and they're also using smaller containers to measure larger containers. They don't learn about the standard units until grade 4. Time concepts are very different, and that's okay. It lines up with the research very well, because they say that kids are really in grade 1 and 2. They may be able to tell time. They're reading an instrument, but it doesn't mean they understand what it is. So in grade 1, they're looking at telling and marking time on a calendar. What I've done in Math Place is I've integrated this as you probably would naturally throughout the year. This is something you're doing on a daily or a weekly basis, and the kids are working with tracking what's happening, and it pertains to their real lives. Grade 2 has to do with the passing of time. They're working in standard and non-standard units. Again, they're not telling time. They're learning how many seconds are in a minute. They're understanding, they stand still for a minute to understand what a minute is, but they are not actually telling time. This doesn't happen until grade 3. All right, I'm just gonna go a few more minutes and then I'll have some question time. Financial, I wanted to get in this because this is a brand new strand. The overall expectation for the primary grades is demonstrate an understanding of the value and use of Canadian currency. You'll notice that the values are different here. Grade 1, they're doing coins to 50 cents and coins and bills to $50. What you'll notice is these do line up with the numbers that the kids are studying in number. That is why we put number in with financial literacy in Math Place. So the kids are doing coins to 50 cents and bills to $50, not a mixture of the two. The same with grade 2. Kids count and compare numbers up to 200. So they're doing money amounts up to 200 cents, just using cents, or $200 just using dollar coins or bills. Grade 3, they're working up to amounts up to $1,000, but they're also making change for whole dollar amounts. So there's a big change. Now, grade 4 is where they start working on, how we can make transactions in money and whatnot. But what I've done and what all my writers have done is we have integrated all of the problems that have to do with money into real life context. So it has a lot of meaning for the kids. So the kids can see themselves and what their parents do and how money is important to their lives. So we're starting to instill that early. We also have a lot of great activities. You'll notice the new $10 bills are there. I haven't seen one myself yet, but they're there for the kids to study. Kids can learn a lot of interesting things about our money. And there's a lot of different activities that they can do in order to find equivalent amounts. We've built a lot of the financial literacy, like I said, into a context that's fun for the kids to do. Lots of problem solving for the students. Easy for you to pull up and do this. Again, you'll see how much of the number that they're doing, because the numbers are the same. They're really doing a lot of the same skills that they're doing in number. And there's a lot of digital slides and Blackline Masters to support this. Number and operations, you'll know this is what I already talked about. This is where the whole numbers are now. Whole numbers to 50, whole numbers to 200, whole numbers to 1,000. We want to incorporate the spatial reasoning. I'm running out of time. So basically with the number, I'm just going to show where the differences are. I use a lot of quick images, by the way, in Math Talks. So a lot of these things are already in there. You could do them with your kids. You show them for a short period of time. You ask them what they see and how they see it. Tons of them in there to work with. You don't have to make a thing. We want kids to be able to estimate. I used to have an estimating jar in my room where kids, and I would change the size of the jar and the size of the things in the jar to help them. There's a lot of problems with creativity. Kids can make place value robots. All the stuff, again, is in there. We're getting kids to see quantity and counting in a visual perspective. Here are the changes in the operations. You'll notice that kids now in grade 1 are adding up to 50. Again, we're using a lot of composing and decomposing numbers to be able to do this. You'll notice that the math facts in grade 3, they're now only doing the multiplication and division for 2, 5, and 10, and they don't do standard algorithms now until grade 3. And I've already talked about how we really want to make sure that we are taking the conceptual understanding, because when I read about the curriculum now in the papers, they're saying, oh, kids are back to memorizing facts, and that's not true at all. They're taking the conceptual understanding, they're taking it to develop those strategies that will help them to recall math facts. So those are the main changes. There's a few more, but those are the big ones that I wanted to talk about. So I wanted to leave 5 minutes at the end here. Sorry for going so fast and so quickly. I just had lots to talk about. And I'm going to quit sharing my screen and see if we have some questions that we could talk about.
We most certainly do. There's lots of chatter going on out there. One that popped up a few times was just a clarification on the acronym HIP, H-I-P.
Oh, sorry. I was using it. That's just for me because I didn't want to print it on my screen. It's high impact instructional practices. So the high impact is the H, instructional practices. I guess I should have made it high HIIP, but it looked funny to me. So.
Sure, okay. So that answers that.